Assalamualaikum. Today I'm from Group A4. We'll explain about software design principles. Topic outcomes to introduce the process of software design, to describe the different stages in the design process, to show how object-oriented design strategies, to discuss some design quality attributes. Developer approach. Skip requirement engineering and design phase and start writing code. Why? Design is a waste of time. Need to show something to the customer real quick, judged by amount of log per month. Expect or know that the schedule is too tight. Design is not programming. Design is not modeling. Modeling is part of the architecture design, part of requirement. Requirement is what the system is supposed to do. Design, how the system is built. First level design, the most way effective to enable stakeholder to understand, reason, and communicate about the system before it was built. A high level model of a software system. Describe the structure, functionality, and characteristic of the software system, understandable to many stakeholders. Allow evaluation of the system properties before it is built. Provides well understood tools and technique for constructing the thing from its blueprint. Intermediary level of design. Useful tools and technique implement architecture in a that way that present its properties is a software system blueprint consists its component, their interaction, their interconnection. Design detail level. Aspects that are relevant in terms of architecture in software system are we design the software, but we must consider the hardware and the environment. Design must reflect requirement, and we must able to relate each requirement with part of the design. Software design. A meaningful engineering represent of something that is to be built, deriving a solution which specifies software requirement. An iterative process transforming requirements into a blueprint for constructing the software. Software design principles should not suffer from tunnel vision, trans- traceable to the analysis model or requirements, reinvent the wheel, minimize the intellectual distance between the software and the problem as it exists in the real world, exhibit uniformity and integration, be structured to accommodate change. Software and design principles should be structured to degrade gentle e- even when even when aberrant data events or operation conditions are encountered. Design is not coding, coding is not design. Design should be assessed from quality as it is being created, not after the fact. Review to minimize conceptual scientific errors. Software design fundamental concept, that is abstraction, architecture, pattern, hierarchical structure, adaptability, understandability, limit complexity, information hiding, separate of concern, modularity, that is coupling and cohesion. The design process, informal to formal design. System should be described at several different levels of abstraction. Design takes place in overlapping stage. It is artificial to separate it into distant phase, but Some separation is usually necessary. Design stage. Problem understanding. Identify one or more solutions. Describe solution abstractions. Repeat process for each identified abstraction until the design is exceed in primitive terms. Process phase. Architecture design. Identified subsystem. Abstraction specification. Specified subsystem. Interface design. Describe subsystem interface. Component design. Decompose subsystem into components. Data structure design. Design data structure to hold problem data. Algorithm design. Design algorithm for problem functions. From requirement to architecture. Determining exactly what the customer and user want. Specify what the software product is to do. Requirement specification to architecture is planned to design the system, decompose software into modular with interface, specify high-level behavior, interaction, and non-function properties. From requirement to architecture, consider the key trade-off, which is schedule versus budget, cost versus robustness, fault tolerance versus size, security versus speed. Maintain a record of design, decision, and traceability. Specify how the software product is to do its task from design to programming. Advantages of explicit architecture. From requirement to design is from design to programming, testing, and maintenance. Stakeholder communication is architecture may be used as a focused discussion by system stakeholders. System analysis is mean that analysis of whatever the system can meet in non-functional requirement is possible. Large-scale reuse is the architecture may be reused across a range of systems. Architecture and system characteristic. The system must be designed to achieve performance, security, safety, reliability, availability, maintainability, and quality. Architecture design process. System structuring. A system is decomposed into several principal subsystems and communication between these subsystems are identified. Modular decomposition is the identified subsystem are decomposed into modules. Control modeling is a model of the control relationship between the different parts of the system is established. Quality. Design quality is an elusive concept depend on specific organizational priorities. A good design may be the most efficient, the cheapest, the most maintainability, the most reliability, etc. The attributes discussed here are concerned with the maintainability of the design. Quality characteristics are equally applicable to function-oriented and object-oriented design. Design abstraction, procedural. Procedural abstraction, natural consequence of stepwise refinement, name of procedural denotes sequence of action. The design concept, abstraction data, data abstraction aimed at finding a hierarchy in the data. Modularity, structure criteria which tell us something about individual module and their interconnection. Cohesion is the glue that keeps a module together. Coupling is the strength of the connection between cohesion. A measure of how well a component fits together. A component should implement a single logical entity or function. Cohesion is a desirable design component attribute as when a change has to be made. It is localized in a single cohesive component. Various level of cohesion has been identified. Cohesion levels. Coincidental cohesion, weak, is part of a component are simply bundled together. Logical association, weak. Components which perform similar function are grouped. Temporal cohesion, weak, is components which are activated at the same time are grouped. Procedural cohesion, weak, the element in the component make up a single control sequence. Communicational cohesion, medium, is all the elements of the component operate on the same input or produce the same output. Sequential cohesion, medium, is the output for one part of a component is the input to another part. Functional cohesion, strong, is each part of a component is necessary for the execution of a single function. Object cohesion, strong, is each operation provide functionality which allow object attribute to be modified or inspected. Coupling, a measure of the strength of the interconnection between system components. Loose coupling means component change are unlikely to affect after components. Share variable or control information exchange lead to tight coupling. Loose coupling can be achieved by state decentralization as in object and component communication via parameter or message passing. Coupling and inheritance. Object-oriented systems are loosely coupled because there is no shared state and object communication using massive passing. However, an object class is coupled to its superclass. Change made to the attribute to operation in a superclass propagate to all subclass. Such change must be careful control. Information hiding. Each module has a secret. Design involves a series of decisions. For each such decision, wonder who needs to know and who can be kept in the dark. Information hiding is strongly related to abstraction. If you hiding something, the user may abstract from the fact. Coupling is the secret decrease coupling between a module and its environment. Cohesion is the secret is what bind the part of the module together. Top-down design. In principle, top-down design involves starting at the uppermost component in the hierarchy and working down the hierarchy level by level. In practice, large system design is never true top-down. Some branches are designed before others. Design reuse experience and sometimes component during the design process. Understandability related to the several component characteristic is cohesion, naming, documentation, and complexity. Informally, high complexity means many relationships between different parts of the design. Hence, it is hard to understand. Most design quality metrics are oriented toward complexity measurement. They are of limit use. Adaptability. A design is adaptable if its components are loosely coupled. It is well documented and the documentation is up to date. There is an obvious correspondence between design level, design visibility. Each component is a self-contained entity, tightly cohesive. To adapt a design, it must be possible to track the link between design components so that change sequence can be analyzed. So that's all for this chapter. Thank you